Welcome guys. So next, before going to the problems on unit 1, I wish to give you about an idea about the various formula used in solving problem in unit 1. So we have various process in first law of thermodynamics for closed system. So those various processes are constant volume or isochoric process, constant pressure or isobaric process, constant temperature or isothermal process, hyperbolic process, adiabatic process, and polytropic process. So constant volume we call V is equal to constant. So V is equal to C, here P is equal to C, here temperature T is equal to C, or PV is equal to C. And isothermal process and hyperbolic process both are same. And adiabatic process PV per gamma is equal to constant. Polytropic process PV per N is equal to constant. And the various parameters which we want to know for these processes are heat transfer, work done, change in internal energy, change in enthalpy, and the pressure volume temperature relation. First, we know that in general, change in internal energy, the formula for change in internal energy is del U is equal to mCV T2 minus T1. So kindly remember this. This is the formula for internal energy. Del U is equal to mCV T2 minus T1, and that is common for all the process. And del H is mCp T2 minus T1, and that is common for all the process. And here, for an isothermal process, temperature is constant. So T1 will be equal to T2. So therefore, this T1 minus T2 will be 0. So that's why it is 0 for change in internal energy, and change in enthalpy is 0 for both isothermal process and polytropic process. And also, in work done, the formula for work done is W is equal to integral PdV. Since for a constant volume process, this change in volume dV will be equal to 0. So therefore, work done is equal to 0. So first, del U formula is mCv T2 minus T1. Del H is mCv T2 minus T1 for all the process. And in isothermal and hyperbolic, this del U and del H is 0. And work done for constant volume process is 0. And also adiabatic process, normally what is adiabatic process is, there is no heat transfer from system to surrounding. So from system to surrounding there is no heat transfer. So therefore Q is equal to 0. So first of all in tabulation beside the place 0 will come, I have told you. So first remember that. And also del U and del H is mCv T2 minus T1 and mCp T2 minus T1 for all the process. And now heat transfer Q, it is, and here we know that first law of thermodynamics says that Q is equal to del U plus W. Summation, this Q is equal to summation of del U plus W. And here W is equal to 0. Then Q will be equal to del U. Q is equal to del U. So therefore, Q for constant volume process is the same formula for the change in internal energy formula. So it's mCv T2 minus T1. So for constant volume process, heat transfer is mCv T2 minus T1, and constant pressure it is mCp T2 minus T1. And Cv is specific heat at constant volume. Cv is specific heat at constant volume, and Cp is specific heat at constant pressure. Specific heat at constant pressure. And work done for constant pressure is, since work done is W is equal to integral PdV, therefore pressure P is multiplied by V2 minus V1. Or also we know that by ideal gas equation PV is equal to MRT. So this P2 V2 can be written as MRT2 and P1 V1 can be written as MRT1. So we can take MR common as T2 minus T1. So this is work done formula for constant pressure. And now for heat transfer for isothermal process is Q. We have a separate derivation for this. If you want, I can give that. You can just kindly ask me during the lecture hour, or you can text me the official clue. So Q is equal to P1 V1 ln V2 by V1, or Q is equal to P1 V1 ln. We can also replace this V2 by V1 as P1 by P2, and P1 by P1 V1 is equal to MR T1. So I have already again replaced the P1 V1 with MR T1. And here is del is 0. your Q is equal to W. So the same what formula you are using for Q is the same formula can be applied for W, and both processes are same. So only if you know only one tabulation, then complete the four remaining three cells. And for for polytropic process, work transfer is W into gamma minus N by gamma minus 1. W is work done into gamma minus N by gamma minus 1. And work done for adiabatic is P1 V1 minus P2 V2 by gamma minus 1. P1 V1 minus P2 V2 by gamma minus 1. And the change in adiabatic and polytropic is the index will change. So PV per gamma, here instead of PV per gamma, it is PV per N is equal to constant. So the work done formula is same as adiabatic process. The one change is here gamma, instead it is N here. And we have pressure temperature relation. Here since volume is constant, that's why from general characteristic equation we can write this relation. So kindly go through this various pressure volume relation, that will be useful for you to solve the problem. Thank you.